We're now ready to start studying circular motion. Now, in this series of videos, our goal is going to be first to look at a bunch of these topics. Okay, we're going to discuss basics of circles, radians, degrees, and all. We'll study some elementary trigonometry. We'll just discuss it from the point of view of the unit circle, just to get an idea of very basic stuff. We'll go into the kinematics of circular motion. That is going to be the quickest one because I expect you to already know the kinematics of translational motion, one-dimensional motion, and we'll use that as a basis to obtain the equations for circular motion. Okay, then we'll go on to study uniform circular motion. We'll apply it to a bunch of things. Then we'll study non-uniform circular motion concepts and then apply that also. Okay, so let us begin by looking at some basics about the circle. Okay, so what is a circle? A circle is a set of points that are equidistant from a fixed point. Okay, the fixed point is what we call the center of the circle. Okay, and the set of points are what lie on the circle itself. So there are a few properties that we know about circles. We know that a circle has some fixed radius, some length called the radius, which is the distance of the from the center of the circle to any point on the circle. So that remains fixed. Now, as you move along the circle, what we realize is that the radius remains fixed. However, the angles change, and that's what we're going to do. Very soon we'll define these quantities called, instead of talking of displacement, we'll define something called angular displacement, angular velocity, angular acceleration, and all those quantities. And you'll see that they'll be very intuitive, like very simple, straightforward to deal with once you've understood all the stuff in one-dimensional motion. So we have a circle, and let us look at just some very quick properties. The first of all, let us look at units. Okay, now from elementary geometry, you all know that when you go around a circle once, okay, if you complete one revolution around a circle, you complete an angle of 360 degrees. So one complete revolution, corresponds to 360 degrees. Okay, however, in this chapter, okay, we will use, instead of degrees, we'll use radians. And you also probably know from some elementary stuff that this one complete revolution corresponds to 2 pi radians. Okay, now as soon as you know this conversion, the 360 is equal to 2 pi, you can figure out the rest of the angles. Okay, this tells you that 180 degrees corresponds to pi radians. Okay, 90 degrees corresponds to pi divided by 2, and so on and so forth. Okay, 60 degrees corresponds to pi over 3. 30 degrees corresponds to pi over 6. Somewhere in between, 45 degrees, that corresponds to pi over 4. And of course you can figure out all these values from the circle itself. Okay, it's always a good exercise to do this, figure out the values, and then once you do it once, you'll remember it. Great. So this just gives us conversion, how to go from radians into what's it called, degrees, and degrees into radians. Okay, now we can also look at some other very basic stuff, which is the unit circle, along with trying to figure out the angles for some elementary, or rather sines and cosines for some of the basic angles. Okay, now by unit circle, what we mean is that a circle of radius 1. Now, if the circle has radius 1, okay, using this circle, we can figure out the values of sine, cosines, and tangents for a lot of the elementary angles. That's 30, 60, 45. And once you know those angles, you can fill in a lot of the other stuff. So here's the simple way of doing it. Let's look at the 30 degree angle. Okay. Now, if we were to drop a line from the point on the circle to the x-axis, what we notice is that the coordinates of this point, x comma y, okay, they end up being nothing but the sine and the cosine and the sine value. Okay, so the x coordinate is the length, the x length, and the y coordinate is this length. Now we know from our definition that cosine of theta, cosine of any angle, is equal to the adjacent side of the triangle over the hypotenuse. The adjacent happens to be x, hypotenuse is 1, so cosine is simply equal to x, and similarly sine of theta is equal to the opposite divided by the hypotenuse, and it is simply equal to y. So when we have this x and y, essentially if you know the coordinates, you know the cosine and the sine. Okay, so this of course only works for the unit circle, but you can scale this to anything else you want. Now, so in order to find the sine and cosine values, all you need to do is find the x and the y coordinates for any angle. So now if the angle is 30 degrees, okay, let's figure out the x and the y coordinates. We know that the hypotenuse is 1. Here's a simple construction we can do. Okay, we can complete this triangle. Let's just do this here. Okay, add this line and complete it over here so that this angle is also 30 degrees. So what we know is that the side here is 1. We have 30, 30, which means we have so if we just complete this, what we end up getting is that this angle is 60 and this angle is 60. So we have an equilateral triangle. Okay, and if you have an equilateral triangle, what you know is that this entire side here is 1, which means half the side is half. Okay, great. So once we know this, we can figure out this third side by using the theorem of Pythagoras, where if that side is x, then that x is equal to square root of 1 square minus a half square, which happens to be square root 3 over 2. So now for the 30-degree angle, we figured out the coordinates. The x coordinate is square root 3 over 2, the y coordinate is equal to half. Okay, so x is equal to square root 3 over 2 and y is equal to half. Now that we know this, we can figure out simply our cosines and sines. My cosine of 30 is nothing but the x coordinate, square root 3 over 2. My sine of 30 is nothing but the y coordinate, is equal to half. So we know everything for this triangle. And once you know this, we can also figure out tangent. Tangent of 30, okay, is equal to y over x. So it is equal to 1 over square root of 3. Great. We found everything for this one. Okay. We could play the same game and figure out the values for 60. And you see that for 60, all that happens is that you just, instead of okay, so let's just draw the 60s. For 60 degrees, if the angle is, this is 60 degrees, okay, I can draw another equilateral triangle like so. And this gives me, this is 60, this is 60. So if this is 1, this becomes a half. And so the y coordinate here becomes square root 3 over 2. And so our coordinates are simply equal to half and square root 3 over 2. And this gives us the cosine of 60 is half and sine of 60 equals square root 3 over 2. So we get all the values. We can do the same thing for a 45-degree angle, and essentially what you end up getting is, if you were to look at the 45-degree angle, what you end up getting is, if this is 45, this is 45 degrees. Draw another perpendicular from here, okay, and here we'll just use a slightly different tact, because what we know is that if it's a 45-degree angle, if this is 90, this also is 45, which means you have an isosceles triangle. Let these sides be A, and from Pythagoras theorem we know that a square plus a square equals 1 square, which means 2a square equals 1 square, which means a is equal to 1 over square root 2. So now we know the coordinates of this is 1 over square root 2, 1 over square root 2, and this gives us cosine of 45 equals 1 over square root 2, sine 45 equals 1 over square root 2. Now frankly, once we know the values in one quadrant, we can go ahead and fill those values for the rest of the circle. Okay, and this is a very simple exercise. Just once you know the angles, so for 30 degrees, the values are square root 3 over 2 comma half. So those are my sines and cosines. For 45 degrees, they are 1 over square root 2, 1 over square root 2. For 60 degrees, it's half comma square root 3 over 2. For 0, it is 1 comma 0. So those are the values for sine, cosine and sine. For this, it is 0 comma 1. Okay, and then as we go here, we can figure out the rest of the values. Okay, all that happens is that the corresponding signs will change. So this would be negative square root 3 over 2 comma half. So this would be for 150 degrees. For 135, you would have minus 1 over square root 2 comma 1 over square root 2, and this one would be minus half comma square root 3 over 2. So this would be the last one. So this would be for angle 120 degrees. This would be 135 degrees. This would be 150 degrees, and it will be minus 1 comma 0. 180 degrees, and you can go ahead and fill the rest of the circle. Okay, so this is something that you should know, should be familiar with, and make sure, just derive it once, and then you'll remember it, pretty much. Or even if you don't remember the values, it's always a quick derivation, so it takes about a minute to derive everything, and then life is good. All right, so that is just to give you an introduction of just into circles.